Hello, this is a college algebra video, and my name's Dave. Okay, so this is section 4.4. I think I finally got it so that we will not have to stand sideways. All right, so I've got a bunch of problems that don't take too long to do. So we're talking about logarithmic functions, which I just call log functions. That's what most people say, log functions, which is short for logarithmic functions. Here's the first question. Find the domain. So for the first question, I want to find the domain of log base 3. So the base is this small number, subscript. That's called the base of the log. Every log has a base. And then this number is called the argument. So you can only take the log of a positive number. So the domain of log base 3 of x is going to be all x that's positive. It can't be 0. It cannot be negative. You can't take the log of 0 or the log of a negative number. So I'm going to write my domain in interval notation. 0, comma, infinity. All parentheses. This means all positive numbers. So that's our answer for the domain of this function here. Here's my next question. Find the domain of this log expression. So the domain is all about your input. You can only input a positive number. For domain, I don't really care what the base is, and I don't care about this vertical shift. I only care about the input, which is called the argument of the log. So what I'm going to do is set the argument greater than 0 and solve it for x. So I'm going to write 3x minus 1 is greater than 0. When I add 1 to each side, this implies that 3x is greater than 1. Dividing by 3, this implies x is greater than 1/3. I'm going to write it as an interval. Parentheses 1/3, comma, infinity. So as long as x is bigger than 1/3, we're guaranteed this argument is positive. And we're done with the first question. Second question, change the exponential form. This is called exponential because all exponential forms have a base, which is the large number, an exponent, which is the raised number, and then some number. So this is true. 2 to the 3rd power equals 8. This is called exponential form because you see an exponent. We can always change exponential form into logarithmic form. They're very back and forth. You can go back and forth from exponential form to log form. So how do I write this exponential form into log form? First thing I'm going to do is write the word log. And then what's the base of this log? It's going to be the same as the base of the exponential form. The base is clearly 2 in exponential form. So in log form, you do a little subscript for the base. And then here's something to remember. The log of a number is always equal to an exponent. The exponent is 3. So I'm going to write log base 2 of 8 is equal to 3. And I'm done. This is log form. This gives me the same information as this. Remember, the log of a number is an exponent. So when the base is 2, isn't 2 to the power of 3 equal to the 8? Yes, so that we know we did it correctly. Okay. Now let's do the opposite. Change the natural log of x. ln is the shorthand way of writing log base e. So change the natural log of x equals 4 into exponential form. So for exponential form, I want to know what the base is. So ln, remember, sorry for this blurriness. So ln is the same thing as log base e of x equals 4. So ln always means log base e. So now it's clear the base is e. So what's the base for a natural log? It's e. So write a big E for exponential form. And then what's my exponent going to be? Well, remember, the log of a number is an exponent, or the log of a number is an exponent. So the exponent is 4. So e raised to the 4th is equal to, and now what have I not used yet? I used this, I used that, so x. So x we're going to write there. So again, to go from log form to exponential form, you identify the base, make it nice and big in exponential form. Remember, the log of a number is an exponent, so e to the 4th equals the number, which is x. Done. So this is done. We're done with this problem. And let me box my other answer here. Okay, let's go to the next problem. Change log x equals 8 into exponential form. So the reason why I want to do this problem is because I did not write a base. This is called the common log. If you don't see a base, it's understood to be 10. So I'm going to put a little 10 in there just to emphasize that's a 10. When you don't see the base for log, it's a common log, which means base 10. Just like when you see the natural log, ln of x, that means the base is e, log base e. So now it's more clear. How do I go from log form to exponential form? Well, I'll do my answer right here. The base is 10. That's the base. The log of a number is an exponent, so 10 to the 8th power is equal to x. And we're done. Okay, let's go to the next problem. Evaluate log base 5 of 25. Notice the argument is positive, as it should be, knowing the log of a number is an exponent. The log of a number is an exponent. Of course, you got to know what the base is to get your answer. The base is 5. So if the base is 5, what's the required exponent to give me the number 25? And the answer is 2, because 5 squared equals 25. So because the log of a number is an exponent, and if the base is 5, 5 to what power gives you 25? The answer is 2. So that's your final answer. Log base 5 of 25 is 2, because the log of a number is an exponent. When the base is 5, the required exponent is 2 to give me the number 25. All right. We got 3 more problems. State the inverse function for this exponential function. So here's a rule of thumb. The inverse of an exponential function is a log function, and the bases must be the same. This is clearly an exponential function because my variable is in the exponent. So here we go. Without any work at all, I'm going to write my inverse function, which is denoted like this, f inverse of x equals, write the word log, because the inverse of an exponential function is a log function. Every log needs a base, and what's the base going to be? The same as this base. So 3. So f inverse of x equals log base 3 of x. And that's it. That's it. We're done. That's our final answer. This is the inverse function. Now let's go the other way. I'm going to give you a log function, and we want to find the inverse. Find f inverse of x. So I just worded it slightly different to give you a different look. Same thing though. So if this is my given function, which is a log function, I know the inverse function is going to be an exponential function, because the inverse of a log is an exponential, and vice versa. So here comes my inverse function. I'm going to write f inverse of x is equal to, what's the base of my exponential function going to be? It's going to be 4, because that's the base for the log. And then to the x power. So these undo each other. They're inverses of each other. And then finally, let's solve a log equation. Here's my log equation. Log base 2 of 2x plus 1 is equal to 3. So how am I going to solve this log equation? By rewriting it into the equivalent exponential form. Let's put this into exponential form, and that will make our job a lot easier. So what's the base? 2. What's the exponent? Well, the log of a number is an exponent. So 2 to the 3rd power is going to equal this argument. So that's what I'm going to do. Rewrite the log form into exponential form. 2 to the 3rd equals 2x plus 1. Let's get the x term by itself. So subtract 1 to each side of the equal sign. Subtract 1 to each side. Now, 2 to the 3rd is 8, because 2 times 2 times 2 is 8. So think of 2 cubed as 8. What is 8 minus the 1? 7. So 7 is equal to 2x. These ones cancel. So 7 is equal to 2x. Divide each side by 2 now to get x by itself. Dividing each side by 2, I'll draw it lightly, over 2, over 2. So 7 over 2, just write it like that if you want. 7 halves is equal to x. Or you could write 3.5, because 2 goes into 7 3.5 times. Now, before I box this answer for log equations, you always must make sure that your answer for x makes this argument positive. If this argument turns out to be negative or 0, I must reject the solution. And in this case, say no solution. But this is going to be okay, because 2 times 7 over 2, the 2's cancel, I get 7. And 7 plus 1 is 8. This argument is positive. And sure enough, isn't log base 2 of 8 equal to 3? Because 2 to the third power is equal to the 8. So I'm going to box my answer. And we are done at 10 minutes and 40 seconds. All right, hope everyone is doing well. Go strong!